Hello students, this is Dr. S. Venugopal from Cynohub. Today we are going to discuss what is data model and different data models in database management system. Before going to that, what actually data model? In an easy way, if you want to understand what is data model, it's a visual representation of data elements and connection between them. So what is data elements and connections we'll cover in the coming slides. So majorly the data model describe how database logical structure is represented in real time whenever a data is available in the database. So before going to create the database, this data model helps to represent or create the database. Next is, nowadays all enterprise requires properly defined data and formatted data. So to represent that, we require the data model is the one of the. In continuation of that, it helps to design a conceptual, physical and logical level. So whatever we covered, the levels of database management system to helps to design conceptual, physical and logical levels. Then it provides a clear picture of data making. It is easier for whom? The developers. So if developer want to create a perfect database, so they require the data model helps. What we can represent data model? A conceptual, physical, logical levels we are going to mention so that he can prepare a good database according to the company, according to the enterprise place, right? So these data models are used to describe how the data is stored, how it is going to access in real time, how it is going to update as per the user requirements. So when a data model specifies in a clear picture so that you can recognize how the data is going to store, whenever updates are required, how they are going to update, whenever they access by using some queries or by giving some request, how they can access, they can easily understand from this data model concepts. In that, it contains set of symbols and text are used to represent so that all the members of organization can understand how data is organized. So one more important use is whenever all the symbols, some text, diagram representation are represented, this explains everything to the user in the organization, how data is organized properly as per the requirement. That also one of the use of data models in DBMS. So discussed in the previous slides, the use, who will going to use, what is the conceptual, physical and logical layers. Using these types of data models only. So if you are representing physical level, logical level, all conceptual level, so which concept they are going to use is, these are the different types of data model concepts in DBMS. In that, hierarchical model, network model, ER model, relational model, object-oriented data model and object relational data model. So we'll cover one by one with simple example. So first we'll cover hierarchical data model. It is the oldest data model compared to the remaining list. So in this case, the data is organized in a tree structure. The data is organized in a tree structure. So what is this tree structure data is? This can be easily visualized because each record in DBMS has the property of one parent and many children concepts. So if you observe the diagram, the data model is vehicle database model. Suppose a vehicle is classified into two-wheeler, four-wheeler. Again, two-wheeler classified into bike, scooter, and four-wheeler classified into car, tractor, minibus. Again, car is classified into sedan, SUV. See this, if you represent, this is a road, children 1, children 2. Again for this, there is a sub-children's, the sub-children's, and for this, there is sub-children's. This is like a tree structure database. So what is the main drawback of this hierarchical data model, which is represented in a tree structure? There is a property called one-to-many relationships. One-to-many relationships. Suppose if you say, assume this is the parent, this is a child 1, 2, 3. Now in this case, this is the parent, this is the child 1, child 2. If it is a case, there may be a chance of child 1, 2, 3. So this is a depth too many relationships under the model. Hence, this hierarchical data model is very rarely used in the nowadays. Next, coming to network model. So is a generalization of the hierarchical data model. So somewhat different from the hierarchical data model. It allows many-to-many relationships. The hierarchical model represents one-to-many relationships, but this network model explains many-to-many relationships. Therefore, in this model, a record can also have more than one parent. Right? So you can see the graph here, a graph, and hence it replaces the hierarchical tree with a graph in which object types are a node and relationships are the edges. You can see the diagram here. So college, department 1, department 2, department 3, and there is a director. So if you see here, all three departments are linked with the director, which was not possible in the hierarchical data model. So if you observe this diagram and previous hierarchical model, so this is not possible. So in this case, what you can observe is many-to-many relationships. Suppose, for example, if I say a director is maintained a department. Now, one or more departments is linked with the one director. So, one-to-many. Or number of directors will maintain different departments or different colleges. So based on that scenario, you can see many-to-many relationships is possible between one object to the other objects or one node to the other node. So this is one of the example of network model. Next, coming to ER model, means entity relationship model. So this is a well-known, a very used model in the database management system. It's a high-level data model. It describes the structure of the entire database in a pictorial manner, in a diagrammatic representation. That is called ER diagram. So whenever a data you are representing in a high-level data model, so to represent the structure of the database using a graphical symbols, that is called your ER model. So in a simple one, ER diagram is used to represent the actual logical structure of database. So also this discussion in the previous classes, what are the elements are required to represent ER model? You can see the video. So basically ER diagram is used to represent the logical structure of the database easily. So what is the use of representing ER diagram in DBMS? Who can use? Means developers can easily understand the system just by looking ER diagrams. Means under ER diagram you can represent what are the table names, attributes, relationships, easily you can represent. So that's why the developers can easily understand complete data structure of your DBMS. At first, we'll have a look at the components of ER diagram. So in this slide, you can observe what are the different components. So if you see here, employee, company, these two are tables. I mean, call entity. Coming to for every entity, so for this employee ID, name, date of join. So this we can call it as a attributes. For this company entity also, registration number, company name is also a attributes. Then how you can show the relationship between employee and company is using the relationship notation. That is, circle represents employee works in company. So this works in company represents the relationship between these two entities. So this is a simple example, the representation of ER diagram. From this, you can easily guess these two are entities. So these are attributes. So this is called relationship. This is what a simple understanding of every employee or developer of that particular company database. Coming to relational model. So this is most widely used accepted data model. Why? Because the database is represented in the form of rows and columns. Generally, you can observe it's a two-dimensional table. Right? So what each row and column represents is, a row represents a tuple that contains all the data of individual records, while each column represents the attributes. That is what a relational model in the database. So only two things, rows and columns representation of your data, that is called relational model. In that, rows represents tuple, the column represents the attributes. You can see the example. This is a complete table, that is two-dimensional table. So in this is an attribute 1, attribute 2, attribute 3. Now what are the tuples here? Each record is a tuple. Assume that this is record 1, record 2, record 3, record 4. So 4 records in this particular entire table with 3 attributes. So you can see student with attributes such as student ID, name and branch, which consist of 4 records, or we can call it as in DBMS tuples. This representation is basic of relational model. In continuation of relational model, next is object-oriented data model. This is somewhat depth of after relational model. So object-oriented data model is a combination of object-oriented programming and relational data model. So this relational model we discussed in previous slide. It's a combination of object-oriented programming and relational model. So in this model, the data and their relationships are represented in a single structure, which is known as object. For example, there is a relation between employee and department. Here there are 2 objects are available. One is employee E is an object, for example, department D is an object. For every object, again there is a properties, like for employee, I mean attributes, name, job title, phone number, salary, department ID. Right? So for department, there are attributes, that is structure, department ID, department name. So if you see the previous relational model represents entire records, I mean tuples in a rows and column wise. But in object-oriented data model, the object-oriented programming plus relational model combination is called your object-oriented data model. So in this, you can observe the objects are represented like in this particular form. For every object, the attributes are defined. So the above image explains we have two objects, that is employee and departments, in which all the data is contained. That is a single unit, that is called your object. So they are linked with each other and they share the common attributes. What is that common attribute is? Here under employee, department ID, and the department object, department ID is a one more. These two are common attribute they are sharing between this and this table. Next, continuation of object-oriented relational data model. Now the previous whatever we discussed, that is again linked to the object relational model. So what is the previous one? Object-oriented data model, but this is an object relational data model. If you observe, the object relational data model is an integration of object-oriented model and relational model. We discussed already what is relational model. We discussed already object-oriented model. Now it's an integration of these both. Then that represents the object relational data model. Since it inherits the properties of both the models, that is object-oriented model and relational model. So supports objects and classes. It's like object-oriented data models and tabular structure of the like relational model. If you see the example, so this is an relational data model representation. What I told, there are attributes and tuples. This is representation of relational data model. But in detail, if you see, so if you take individual name, phone number, assume this is one of the object. For every object, you can see here name equal to Paras, phone number equal to 9415 some number. If you take one more, name equal to Tanish and phone number equal to so and so. This is the representation is objects oriented data model. So entirely this representation is called object relational data model. So that's why in the definition explains it's a integration of object oriented data model and relational model. So hope you understand this object models like object oriented model, object relational model and other particular models with an example. Thank you.